Hello everybody, Assalamu alaikum, hope you are doing well. This is a video about Taylor expansion or limited development. We can find limited development in French, Arabic, French, but not in English. In English we say Taylor expansion. This is to approximate function by polynomial in a near of a given point. So we give a point if the function is smooth enough, but we can propose an approximation by polynomials at a given order. Here we will practice on three functions, but different way. So the first one is the function f of x, which is equal to ln 2 minus x over x. We will propose the Taylor expansion for this function at the point x0, which is equal to 1, and the order 2. Sorry for the pen, I changed the bullet, but it's still not very clear. It's comes, yeah, it's okay. What we can do, it is simple, since we are dealing with this function near x0 equal 1 is differentiable, so we can use the formula x0 equal 1, so let x be equal to 1 plus y. When x is around 1, y is near 0. So, and our function will be, actually it will be, we can use more than one way, so I will apply just two given ways. This will be equal to 1 plus y, which is equal to ln 2, x is equal to minus 2 minus 1 minus y over x is equal to 1 plus y. Y is actually near 0, and this is equal to 1 over 1 minus y ln 1 minus y near 0 to order 2. So ln 1 minus y near 0 to order 2, this is equal to y minus y square over 2 plus o y square, and 1 over 1 minus y, this is equal to 1 minus u square plus u square plus u square. So we take both of them. This will be equal to y minus y square over 2 times 1 minus y plus y square plus o y square. This is a technique. It's allowed us to calculate these times. This O of y square and this O of y square are not supposed to be the same, but this is what we use. And this is equal to y minus y square over 2 plus y power 3, so this is in y minus y over skew y square, so minus y square minus y square plus y power 3, it is in O of y square minus y squared over 2, this one, minus power 3, so plus o, and this is equal to y minus y squared over 2 over, this means minus y minus 2y squared plus o y squared. This is the development if I didn't make errors in calculation. This is a way. The second way, we can use the differentiation of this function. We can propose, this is the first method. I will propose a second method for this exercise. The second method, then we come back to the original function. So it will be x minus 1 minus 2x minus 1 squared plus o x minus 1 squared. This is the development limited or Taylor expansion to order 2 at the point x0 equal to 1. We can also propose another method. This is the same, another method which can be a little bit long but elementary. F of x is equal to a0 plus a1 x minus 1 plus a2 x minus 1 square plus x minus 1 square. If we replace x by 1, this will be equal to 0, equal to 0, equal to 0. So here what we have f of 1 equal to a1, f of 1 equal to f1. This will be ln 2 minus 1 over 1, so ln y 0. You remark that here we have the constant variable. For a1, we will take the derivative, then we replace by x equal to 1, we will get a1. The second derivative, then we replace by x equal to 1, we get a2, and we will have the formula. In this, the second method, it's case of making derivatives of different order to get the coefficient of this function by I think that this is more quick and more smart this way when it's possible. For the second one, for the second function, it's about searching Taylor expansion or Taylor limited development for the function g of x. So here we have g of x, which is equal to ln Neperian logarithm of sine x applied at x0 equal to pi over 2, and for the order 4. Once again, let x be equal to pi over 2 plus y. When x is near pi when x is near pi over 2, so y is near 0, and our function takes the form g of pi over 2 plus y. This is equal to ln sine pi over 2 plus y, and this is equal to ln sine pi over 2, this is equal to 1 cosine y plus cosine pi over 2, this is equal to 0, and this is exactly cosine y. To order 4, so let us write this is the composition of Taylor expansion of two functions, which is cosine y near 0 and ln cosine 1. For cosine 1, we have ln of 1 minus x squared, y squared. This is cosine Taylor expansion plus y power 4 over 4 factorial plus o y power 4. And this is equal to ln 1 minus capital X plus y power 4. And capital X is actually this one. Minus 1. So x is equal to y square over 2 minus y power 4 over 4 factorial. When y goes to 0, x goes to 0, since here we have the right to use the Taylor expansion of ln 1 minus x to power near 0. X is near 0 since it tends to 0 to order 4. So this is equal to 1 plus x square plus x power 3 plus x power 4 plus y power 4. And this is once again we will replace capital X by its value. So here we have 1 plus y squared over 2 minus y power 4 over 4 factorial plus y squared over 2 minus y power 4 over 4 factorial power 2. And I think that I will stop here. Why? Because if we take x power 3, it will be y power 2. Power 3, it's pass over the order 4 plus here plus u power 4. And this is equal to 1 plus y square power 2 minus y power 4 over 4 factorial plus power 2. So here we have 4 u power 4 over 4 plus u power 4. This is actually the final result. Just here we have to simplify. This is equal to 1 plus u square is actually x minus pi over 2, so x minus pi over 2 power 2 plus 1 over 4 minus 1 over 4 factorial minus 1 over 4 factorial. We have to do the calculation of x minus pi over 2 power 4 is power 4 plus x minus pi over 2 power 4. This is the Taylor expansion to order 3. I check if what I write is clear. Yeah, it's clear. It's okay. Let us move to the last one for this video. I will make in a few minutes another video about more hard question about Taylor expansion just before this one. The last one is about h of x, the function h of x, which is equal to 1 plus x squared divided by 1 minus x squared. Let us write it in this formula. So at the point at x0 equal to plus infinity and order, once again, order 4. Let us make here a change of variable. Let x be equal to 1 over y. When x is in the neighbor of plus infinity, y is in the neighbor of 0. So let us move to 0. We know and we recognize formula for variable near 0. This is the useful and the usual functions. So our function x of each of x will take this form. So each of x will be equal each of 1 over y, and it takes this form. It will be 1 plus 1 over y plus 1 over y squared times 1 over 1 minus 1 over y squared. We take this form, and this will be equal to y squared plus y plus 1 over y squared minus 1. What I did, I unified the denominator. So here we get y squared, y and 1, and here we get y squared minus 1. Y squared, they will be cancelled with y squared, and we get this one. Let us write this as minus 1 plus y squared from this, and here we get 1 minus y squared. This will be equal to minus 1 plus y squared times 1 half. Let us take minus 1 half here, and this will be equal to 1 over 1 minus y plus 1 over 1 plus y. Here we have 1 plus y minus y, so it's okay. This is what we need. And it is equal to minus 1 over 2, 1 plus y squared. This is a regular polynomial, so we have not to do any change. For the remainder, we know that 1 over 1 minus 1 is equal to 1 plus y squared plus y power 4 plus y power 3 plus y power 4. For the second, this one, we have plus 1 minus y plus y squared minus y power 3 plus y power 4 plus y pi 4 for each one, which is equal, we already finished. It's about some few seconds. 1 over 2 plus 1 plus y squared times, here 1 and 1, this makes 2, y minus 1, 2 plus 2 y squared plus 2 y power 4 plus y power 4. Here we can make the product. This is equal to, for 2, so we have minus all this times 2, so it will be minus 1 minus u squared for the first, this one. We can take here and we let just 1, and here this will be equal to minus. For the first, it's okay. For the second, we keep minus y squared, minus, once again, y squared, minus y power 3 minus y power 4, we put it in y power 4. For this one, we keep minus y squared, and we keep minus y power 4 plus y power 4. And as a final result, this is equal to minus 1 minus y minus y square minus 3y square, and minus 3 y power 3 minus y power 4 plus y power 4. Now let us move to the first change of variables. So y is equal actually to y is equal to 1 over x. So we make, so this is equal to minus 1 minus y over x minus 3 y over x square minus y minus 1 over x power 3 minus 1 over x power 4 plus 1 over x power 4. This is the final result. Thank you very much for watching this video. I hope that I will see you again for the next upcoming one.